you might be get unexpected result. So it's not good. So there is also has a problem. Then we needed to discuss about that. So what is actually task about? Actually, in the operating system level, we have a two concepts. We have one is the process, and the process is actually it's the memory contain the code and data. So this is the main. Then also they going to schedule CPU time. So it's very important. Then what's the thread is actually rely on one process. Then they can main purpose is executing the each task. So depend on the operating system. Actually, one they have a maximum can take maximum amount of the thread. For example, one thread in the some operating system or 200 around 256 thread they can take care of them. So that's one way to improve the process. So it means all the tasks can be possible to in the one process can be possible to execute with this competing with those thread to accomplish this efficiently accomplish this task. Then another way to doing the parallel task is multi-processing. It's multi-processing. It means actually is sometimes being called parallel processing or parallel programming it is one way to explore it. Actually, it tend to execute parallel. It is mainly applied to this technique in the supercomputer, right? So the supercomputer usually has a more than 30,000 of CPU, right? Can you imagine that they have a 30,000 of CPU in the one big supercomputer? So it means they can even sometimes some supercomputer even might be possible to 1,000 CPU, So I remember some of the they included 30,000 CPU. I remember that. So it means those things can be also doing the parallel task. That's a mechanism of from the computer architecture, then also as well as in the operating system perspective. So, and the operating system perspective, the more classical way to doing the scheduled multitask ways, the managing the take caring the by multi-thread mechanism. So that's a subject we are going to cover today. Why threads matter? Why thread is important? Because while you competing the resource, we have several tasks. We need to sometimes something internet because internet bandwidth is limitation. For example, in the usually we have a upload space or download spaces around 1 megabyte or between the 2 megabyte. So usually this is kind of high speed of if you around such kind of speed, usually we are going to able to able to see this video stream, right? So sometimes, but if you consuming this limit the bandwidth with too much people sharing this bandwidth, you have a limitation of the they have a there must be happen conjunction because they must be split this bandwidth, this total of the amount user, then they must be slow down this performance of internet connection. So that's things in order to give a better performance or maybe give a ideal operation, ideal management, those kind of operation. usually you also can possible to take around this each request from the user. Then another thing is sometimes we have to, sometimes reading, writing the input output block. For example, you want to some several user or several process going to write in the same file. So what will be happening the writing the same file is maybe, for example, one Excel, right? So it's usually if one kind of statical Excel, then you want to change one item inside. For example, maybe your salary, or maybe your, I don't know, maybe you're accessing the completion of your task amount. But for example, if you both are doing the same task, then if you one of them is finished one task, then they after that they will be update this own task amount of and number they going to update this file. At that time, if the two process, I mean two file or two thread, they going to access the same file, what will happen is, for example, you are going to change the number to 10, then second one's going to change it to number to 11. But this time maybe is a they both are coming together, then second one, if second one is going to change to 11, then after that first one is been overridden to 11 to 10. So what will happen is, actually there is a problem. So actually you need to keep the sequence between this to both access of the accessing the file of from the different threading management. So that's a problem. So you need to avoid such a situation. Then that's important to you need to manage the parallel operating thread task. So next thing is how we can create this those kind of multi-thread. Actually, we have a thread class. Then two ways we can implement it. One is extend this thread class. It is one way. Another is there is a runnable interface. So we have two things. One is a class. Another is interface. So both are it's both way we can create this thread. We have a two way, two class. One is the thread, another is the interface. So interface is abstract class. You need to have to be implement this abstract method. And the thread then also has a for example, here's a thread is create one of the thread. They extend the thread, then they going to override this run. So they has a function. So you need to main things is this main job of the thread. So it actually this thread will be going to operate this operation algorithm. Then what's how to execute, how to invoke them from the main, and actually if you create this thread, then they will be going to start, as well as you taking as well as start function has been invoking, then thread will be alive, then they will be involved this full running process. Another, as I said, another is a runnable interface. Then you also need to implement this runnable interface. Then you have to override this run method at the same time. So so this is kind of two things you can able to run this implement this thread class. This is also this if you I mean implementing this one, this is a thread class, then you create a new thread, then start invoking start class, then it is also same create this new runnable, but the main difference is this second line. You have to put this this runnable instance to the thread, then they will be going to invoke. So that's a little bit difference. Uh, while you running the thread, for example, one thread can be runnable several times. So this one should be potentially, potentially should be shared to both thread. For example, here we create the same thread example runnable, but we start to two times. It means we have the both two thread has a I element. So what you're doing is they increment each time. So increment, so from 1 to 100 they will be going to input. But how you can manage the those are same time. So how you can, so they must be sharing this t, right? They going to increase the same time. So so that should be how you can manage this. For example, this should be, for example, in one step, if you spend 1 millisecond, this should be, in order to accomplish this function, you should probably you need to spend 100 millisecond. But while you're running the two method, two thread, should be this two task, in order to print out this from 1 to 100, should be because the two thread came going to running parallelly. So shouldn't be, shouldn't be repeated, but it is should be accomplished this task sufficiently, then as well as correctly. But most time it's not the way to be. We have a most time we will be met unexpected result. So that's the reason you need to manage those thread. So what's the problem of those things? Problem is, while you're running this thread, for example, here's the I0, they must be printed out two times here, then I1, then I2, 3, 4, 5, it's no problem. But there's I there is a disappeared I11, but after then I12, then again is I11. So they know repeat the repetition, but sometimes it is kind of out of our mind how it's possible. It is actually they running in the sequentially. There is no way to, but how is possible to print out such kind of result? So that's the reason you need. That's the problem of our obvious problem. So how we can make this more safe way, or how we can possibly we can output this correct way. So that's the reason, one way that we have a thread is improved our performance. It's very obvious. But but same time they has a problem, such kind of problem we will be faced. So how you can, the next thing is how you can prevent them, right? So there is a non-shareable, you have a make this non-shareable data. Some variable type were never shared, following data is never shared, and always in this thread state. Local variable, method parameter, exception handle parameter, those are, if you, that's kind of principle of, if you didn't if you not share those data, then usually it's not the problem. So that's the main idea of the how you can prevent them. Let's say for example, let's say this the concept of atomic. What's the atomic is actually is never changed. So never changed, never been lose it. But how you can do this way, right? So all the time, so the eyes never be keep the unique property to, for example, all the times one, then two, then threes never happen the two second time. That's the idea of the atomic operation, right? So how we can, if is we expect that, but sometimes if you happen such like that, it's not atomic properties, right? So zeros two times, then it's not the atomic properties. So we expect that this is operation should be atomic, right? So if some class the property is not the atomic operation happen, so it's not the thread safe. That's the reason we mentioned that threading string buffer, it's thread safe, string builder is not thread safe. That's the reason they have something not properly while you're doing the thread. What's the out of order execution? So one thing is that we cannot expect it properly while you output, so there's a output some kind of obvious error, unexplained expectation, so it is already we needed to take around. That's the problem. But there is a one things there is a one method give us possibility to using this keyword violate. While using the violate, they will be give a possibility to keep this this data is been then been violates does not mean atomic, but they will be going to shareable as long as they using this data using the public, then it means how many whatever your uh, whatever your strategies have, they will be going to share this operation. So what will be happen is if you doing the, for example, violate this true, it means both are they will be going to share it. It means while you violating is kind of kind of kind of a shareable element. If I change from the one thread, they're going to definitely they will be able to disable inside with another thread. But if you the local, if you're writing with the local property, then it's not the it's not the will be shared with this another thread, right? uh, then this is why it is public, so it's usually most times they using this property to controlling the some method. For example, you are if you're going to execute quit excited from the program, you can able to use such kind of flag or property to manage this sharing the data. Sometimes it should be useful, but sometimes it's not useful while you keeping this data with with the several thread together. And for example, here's they using the time to quit. This is a volatile property, so they can able to shareables. If you do true, it means you can definitely going to out from the wild circle. There is another keyword being called synchronize. What is synchronize is because we have a problem with sharing the data, but if we expected this definitely some we expected we must be sharing this data, but same times we worry about this out of order. So that's the reason we can use the synchronize method to keep this order. So it's kind of way to we need to keep the order. There is a several way to we can keep the order. One is we can put the synchronize with the method. We can keep this synchronize with the block. For example, it's inside this method, but it's not blocked this in the first level, but they will be blocked this block of the operation. So they didn't block the whole function, but instead of one piece of function. Then also as well as block the object. So this means they only monitoring this object as long as this object just doesn't change or as long as this object has already been monitored, already been finished, then they going to allow to access the other method, other block. So it is synchronized as long as this block of operation didn't finish, other kind of other operation, other thread cannot be been interrupted, because maybe in this during this process they have something operated shareable data. For example, they string builders, as we said, string builders not thread safe. That's the reason they're going to protect. But I think if you're using the string buffer, you don't necessarily just taking this synchronize this method, because as I at that time we mentioned that you can take this method, you can try to run it by yourself, try to realize that. At that time we said that string buffer is not thread string buffer is thread safe, but building string build is not thread safe. So it means this means if you replaced with string buffer, definitely you don't necessarily do string the synchronized method. So at that time you don't need the so it means inside, maybe they already optimized this method inside of the string builder. They already have a lock. They carefully take around, so we don't necessarily to manage by us. So that's the reason, in my opinion. Yeah, as I said, it's also there's a third kind of synchronization is monitoring object status. Yes, there is another method in the thread, interrupted. So interrupt is kind of a little bit interrupt is kind of things that we can able to from one thread to another. They can finish, interrupt, give the stop the thread for execution. Then another thread can take the chance to execute the task. Yes, so just like that. So interrupted method is usually using the stopping the thread. But yeah, then also there's a thread sleep method. Thread sleep method in order to give the chance to another thread to take the chance to execute. So it means, for example, here's the first thread take care of the time too long. Maybe you have to wait sometimes, so you don't necessarily to keep this all the resource inside one thread. So that's the reason they take this, for example, 4,000 of the millisecond, it means 4 seconds. They just sleep the 4 second, then it means sleep means others can take this chance to run it again, other things by chance. Yes, there is another thread method. For example, set names. So set name for thread, set get ID. So each thread has own ID. So is live. It means the thread is already finished or not. Is them is them means kind of is it's kind of the not important thread. It is not the it is background thread, but it's not important for stop the thread. For example, stop this GVM. For example, you are going to shut down your program, but at that time, if there's still has some kind of damned thread existed, there is no problem with stopping the GVM, creating from GVM. But if there is some thread still existed, then it's if it means it's non-demand thread, then you have to wait for until the other thread is finished, then you can able to finish your finished your program. There's another things that joint means, because the sometimes one several work when be finished, then you trying to, you know, several thread going to some kind of sequential order to execute, then you needed to using the join thread. For example, some work, there's a bunch of work parallelly accomplished it, but in order to execute the second of work, have to be take some result from the first bunch of the work. Then, for example, in the there's a several thread from four thread is already taking the first bunch of the work. Then two of them is already finished it, but if there is a some flags join, it means as long as the other threads come together when finished it, then another thread going to doing the process at that moment. You can able to use, it's kind of another many thread to join to with another thread, so it's you can able to manage things depend on your business logic. There is also wait and notify. Notify all. Notify, it means the current threads should be will be wait, but notify all means all of the threads already finished it. Then you can do something other than. So sometimes it should be useful while all the thread or some thread is already finished it. Then you can start with doing another things. There is another method to not recommend. It's already been deprecated. It's already been deprecated means before that they didn't realize that this method should be work, but actually it's not thread safe. So that's the reason they already deprecate. Not recommended to use anymore. It is yeah. There is another problem, very important, while using the thread. They have a problem with deadlock. What's deadlock? It means there is an example that, for example, you synchronize in the first object, and inside synchronize, they have a synchronized second object. But at the same time, in the another thread, they synchronize second object. Then inside the second object, the method they have synchronized first object. What will happen is, while you synchronize first object, right? So same time the second method they come together, they going to synchronize second object. So it means they check the second object. Okay, there has the both are at the first moment they no problem, but at that time the first object already, and at the first and second is no problem, but at the moment they going to say, okay, the first ones come to here check, second's already been looked at. So they expected object 2 has been released it, but object 2 has already been blocked it. They waiting for object 1 to release it. So it's kind of one waiting to another, but there's no way to release to lock, release to this to chance. So it's definitely deadlock. This is a phrasing. So that's a problem of the deadlock. So you need to wisely use this deadlock problem. Okay, that's all of this task. I hope you have a any question, please ask me.